Open your books to page 730. We're going to be reviewing the skills that are in Chapter 9, Lesson 6, finding the area of parallelograms, and we're also going to be focusing on problem solving using those skills. Now, we have been talking about the area of rectangles prior to this, and rectangles are parallelograms, and so are squares. But the difference is that they have all right angles. So if you have a parallelogram with all right angles, then finding the base and the height is like super easy. Whatever's on the bottom is the base, and whatever is on the other side is the height. I'm just going to put H there. Now, but the difference being that parallelograms don't have to have right angles, and so it's not so simple to recognize the base and the height. Let's go ahead and look over here at the parallelogram. This is the black strip in this word problem about someone drawing a picture of Trinidad and Tobago's flag. So you'll see the black parallelogram here in the middle. And this is going to be the base here at the bottom. But the other side is not the height. And that's what we have to remember. It's not the other slanty bit that's going to be the height. It's going to be what is parallel to the base going up is going to be the height. So in this case, this part of the flag is actually going to be the height because we're dropping down from the top here, and then there's going to be that right angle. And as we talked about before, when you slice up the slanty bits and put it back together, it makes a rectangle. So that's how we kind of determine the base and the height. Now for a rectangle, we just call it length and width, and that's the same as base and height. But length and width is not the same thing as base and height for a parallelogram. Okay, so then basically you just multiply those two things together. Now what makes this particular problem slightly more complicated, because you keep base times height, and we have 6 3/4 inches times 12, is the fact that this is a mixed number with a fraction. And so we're going to walk through that here in just a moment. Basically, before you can multiply anything that has a fraction, if it's a mixed number, you need to make it an improper fraction. You are automatically going to have the same denominator. What you have to do is figure out what the numerator is going to be. So that's going to be 6 times 4, 6 whole pieces of 4 over 4. So that's what 6 of these 4 over 4s plus 1 3/4. So 6 times 4 plus 3. Go ahead and tell me what the numerator for this particular mixed number would be in the improper fraction. Very good. That is going to be 27. So then we multiply these two things, but before we do that, we're going to make this into an improper fraction just by putting 1 at the bottom. So the one more skill I want to review here is, because we know the answer is 81, it's right there. How can we do this more easily? And the key to that is to actually simplify before you multiply. So 1 and 27, that cannot be simplified, but can 4 and 12 be simplified? Can we divide 4 into 12, for example? Go ahead and answer that question for me. What is 12 divided by 4? You're exactly right. That is 3. So we could actually rewrite this with an equivalent expression as 3 over 1 times 27 over, and then 4 divided by 4 is 1. So all we have to do now is do the computation of 27 times 3, and that's 21. 3 times 2 is 6, plus 2 is 81. And this is how we get the area of this parallelogram. All right, so at this moment we need to be on page 733. We're going to work through problem 12 together. It is a multi-step problem, so please listen carefully. The first thing we're going to do is read the word problem. Then we're going to underline what we're being asked to find and circle important information. Lee is designing a flower bed for a school project. His design consists of a square inside of a parallelogram. The shaded area will be planted with some small shrubs. In order to get the correct number of shrubs, Lee needs to determine the area of the shaded region once he has the dimensions. Which of the following formulas can be used to find the area of the shaded region? Okay, so I want you to take your pencil and go ahead and underline what we're being asked to find. Okay, so we're looking for formulas used to find the area of the shaded region. And so what would be something that would be an important piece of information for us to circle? Go ahead and do that, please. Okay, the word square and the word parallelogram are important things for us to circle here. As well as really, honestly, the whole picture over here is an important thing to look at. Now you'll notice they don't actually give us any dimensions, so we would not be calculating the area for real, but we have to come up with our plan in order to calculate the area. Now I want you to think back to similar problems we've done like this in a previous lesson, and I want you to answer the question, what will be an important operation for us to use to figure out what this green area is going to be? Go ahead and answer that for me, please. That's correct. Subtraction is what's going to end up getting us the final answer, because what we've done before is we have determined the area or found the area of the larger shape, then we found the area of the smaller shape, and then we subtracted to find the difference, and that left us with the shaded area. Okay, so first off, tell me what is going to be the formula for finding the larger shape? Go ahead and answer that for me, please. That's exactly right. Since this is a parallelogram and not a rectangle, we're going to use base times height. Now they happen to label the base as the top instead of the bottom. A lot of times we'll see it as the bottom, but honestly this is equivalent to this line, so it really doesn't matter. Since opposite sides of a parallelogram, I'm making the congruency marks, are equal. Okay, so base times height, and you'll see this creates that right angle that we need for the height to have. All right, so this is the formula, and not length times width, because length would be the base, but width would be something that is the slanty line that is not the height. Okay. Now what we have to find is the area of this smaller figure. So please tell me, what is going to be the formula to find the area of this figure? That's exactly right. That is going to be actually s squared, because this is a square. Now you'll notice that we could also have discovered that by using the formula length times width, but the length and the width would be the same, but the most accurate formula to use would be s squared. And then the operation that would be important to use would be subtraction. So we're going to determine the answer by area is equal to base times height minus s squared, and that will give us this green area. So now that we've done all this thinking on our own before looking at the answer, we know that C is not right because there's a plus sign. We know, and also it's base times width, and that's not accurate. And then D is not correct because there's a plus sign. We're not going to add the area of the square. And again, so this one's not going to be correct because we're not going to do base times width. So A is going to be the best answer for this problem. Okay, we're going to continue to practice what we know about the area of parallelograms with the next 4 word problems on the next page. Please show up to math class tomorrow in order to work through this together. We're going to do some more examples together, and you'll be able to ask any questions. Math class will be at 2:35 for everybody tomorrow. That is our new pattern of instruction. So at this time, I want you to answer that final question. Don't say, I don't know. Don't say what you taught. Don't say the examples you gave. Be specific or you will not get points for this video. So go back and look at some of the notes. Come up with something that you think is important to remember about this lesson. Go ahead and answer that for me now. Thank you for your thoughtful response, and I will see you later in class.